Hi there, it's Hank Carr from Fork and Cleaver Farm. Today what I thought I'd do is show you these Chinese temperature controllers that we use. And here's one here. This one's been in use and has failed. And this is a model STC-1000. Super easy to find on eBay. They're between $10 and $15 US. And what they do, this one's dirty, it's been in the chicken house. The power goes in here. There's a sensor that plugs in here, and I have one right here. This is a really short one. It goes in there, and this is the temperature sensor. And then this is a heating output and a cooling output. So you set a temperature here, and if the temperature is below the set temperature, this set of contacts is connected. And if it's above the set temperature, this set is connected. So this is cooling and this is heating. And so what you can do is, and what we do, this one has been in the chicken house. So when the temperature goes above 25 degrees Celsius, these contacts close and it turns on a fan. So the fan runs automatically and we don't have to worry about it. Now, unfortunately, this one has failed. And the reason that it's failed is the little relays that are in here, they claim will do 15 amps at 115 volts. That's not true. On this one here, it actually says 10 amps at 220 volts, which is essentially 20 amps at 110 volts. That's not true. It will not do that. So what I thought I would do is take one of these and see if I could modify it to use a solid state relay. This is a solid state relay. And this relay is good for 40 amps at 380 volts, which is more than I could possibly need. But the problem is that these controllers, all they do is they have a relay in them. And what a relay is it's an electric switch, essentially. So the way that the relay works is you have an input and a coil around a rod. And when there's power on here, this rod is magnetic. So what happens is you have a contact here, and a contact here. And this is a pivot, and here are the two contacts. So when this electromagnet turns on, it attracts this, which pulls this arm down like this, and closes the switch. So if you have your fan out here, and here's a fan, and you have power here, then you have your line. So this is your line and this is your neutral. And when there's power across these two contacts, this switch closes and the fan turns on, right? That's how a relay works. The solid state relay doesn't have a moving part. And the problem is here, when this closes, when you're running a heavy load on this, there's a little bit of a spark here. And eventually what happens is this thing welds to this contact, and this wire here, or this wire here, or both, on the board of the controller burn out. And then the controller's no good. So let's look at one of these. So there are two here. This is an Inkbird, which is a pretty decent name. And it's a ITC-1000F. So you can buy this one. I bought this one on Amazon. And then this one is the cheap Chinese one. This is an STC-3008. Slightly different model. So let's have a look at what's in here. So this one has two sensors and two set temperatures. Let's pop this off here. We'll unplug these. We don't need them. There we go. We'll take these little mounting clips off. All right. Now, in order to get into it, we need to cut that label, which is going to void the warranty, but we're never going to warranty this out. All right, so here's a scalpel. So if we go across here and just cut this label, I slipped out of it there. Let's cut the label. And then we'll pry the faceplate up. There we go. All right. So this is the inside of the cheap little Chinese one. Now, these are both made in China, don't get me wrong, but this is the cheaper version. So here's the Chinese one. Here's the two little relays. here's the two outputs, right? And this is the input stage over here. So there's a little input transformer, which is tiny. Then there's a little power supply over here with a voltage regulator. The transformer normally switches the 110 volts or converts the 110 volts down to about 10 or 12 or 13 volts, which is used to drive these relays. But the little controller that's on here that actually runs this controller needs 5 volts. So this is a little voltage regulator that gives you 5 volts. So we have 5 volts here. That's important for later. Let's open the Inkbird and have a look at it. Oop, lost the sensor off of that one. Plastic bag. It's a mess. This is what my desk always looks like. Oops, we got to get that screwed out. All right, so we take this guy off of here. I actually really like these Inkbird controllers. All right, there we go. So let's get some of this stuff. Open this bad boy up. There we go. Pry the faceplate off. All right, let's get this all the way off. There we go. All right, so they're pretty similar. You can see this one has a much larger input transformer. That's very, very good. And this one on the right weighs about twice what this one does. Most of that weight is in the transformer. So you can see the two transformers here. This guy here has a little tiny voltage regulator there. So a much smaller voltage regulator, but that's okay. This is a 7550-2. This is a 78M05. So they give you the same thing. They give you 5 volts. The nice thing about this one is that it's got a little via here that's labeled ground and a little via over here that's labeled VCC. So this is 5 volts over here, and this is not really ground because there's no ground on this, but for our purposes, this is ground. On this guy, there's no vias, so there's nowhere to connect up to. But what I've done through poking around is figure out that this, and I looked up the pin out of this guy, this is the output pin. And it goes to this capacitor. So if we flip this over, this is 5 volts here, and this is ground here. So we can pull off 5 volts in ground, right? Now, what we need to do to modify this guy, what we want to do, let me grab my piece of paper here again. All right, so there we are. Let's get a fresh piece of paper. So in order to drive the solid state relay, which is this guy here, we need 5 volts, or 3 to 32 volts, but we need 5 volts across here. So we need 5 volts and ground. So what I've done is there's the relay. So let me pull this guy up so that we can look at it. So here's the relay. This is the relay. Here's the voltage regulator over here. So here's our voltage regulator. He's got a little tab on him. Then he's got 3 pins coming out. One of those is +5. So this guy here is our +5, regulated +5. And then the input for the relay goes over this way. And then this is the output here, and it goes over to a terminal block. And so here's the terminal block, and here's the relay. And then these are the traces that run to the relay. And then inside the relay, we have the switch and the magnet. So when this gets pulled down to here, these two contacts are shorted. So any wire coming into here like this is just shorted. But that's not what we need. So what we want to do, let's flip this over. So we have our relay. We have our trace coming out. So we've got a trace coming out here. We've got a trace coming out here. So what we're going to do is we're going to cut this trace, right? And then this comes down to here. And we're going to connect this to ground. And we're going to connect this over to the output pin on our voltage regulator. So what that means is that we're sending 5 volts out here, out to the solid state relay. So here's our solid state relay. And that actually should be down here, but you know what I mean. And then this is ground. So what happens is that we've always got 5 volts going out here, but when this relay closes, we've got ground here. So ground gets connected through the relay out to this terminal. Now we have a complete circuit, and the solid state relay turns on. So what we need to do is we need to cut this trace here, connect this to ground, and connect this to 5 volts, and we'll be able to control this solid state relay. So how do we do that? Well, the first thing that we need to do is we need to figure out where those traces are. So let's take this guy because I like him better. So you can see here, these two points here, and this is the relay right here. So these 2 points here are the coil connection that connects to the coil to energize the electromagnet. These ones here are the contacts that come out on this side. So we need to cut these traces. And it sounds really easy. All we need to do is cut this. It's not that easy. There are actually similar traces, and you probably can't see them, on the top of the board, because this carries so much current that if it was a single layer, it would burn out. So what we have to do is we have to pull these relays off the board, cut the traces on the top, cut the traces on the bottom, and then put the relays back. And then we'll move on to the next step. So what I need to do is I'm going to heat up my soldering iron, and I'll get ready, and then I'll come back and I'll show you what cutting those traces looks like. Okay, we're back. All right. So we're going to take these relays off. And I'm not going to use any fancy schmancy equipment to do this. I'm going to use my regular old soldering iron. I have a Weller soldering station that I've used for years and years. Just a plain old pencil iron. Use a solder sucker. I have some solder wick. Little bottle of flux, which I like, and then some fine solder, which I'm going to use to put the relay back on. So we need to get these relays off, which means we need to desolder this, this, and this on both of these. So 4 contacts on each one. And I'm just going to use my solder sucker. It does a pretty good job, so we'll heat this one up. And I'm not sure what kind of solder they're using. It doesn't melt very well compared to the stuff that I use. But it's probably cheap. And if I had a desoldering iron that had a pump on it, this would go much quicker. But I've always managed to get it done like this. So we're going to get all of these off of here. This is pretty straightforward. You could actually use the solder wick for this, and I have done that in the past. A bit of solder. Alright, let's see if this is loosened up. It's not. So I think what's happening is that contacts are sticking to the side of the hole. This one looks like it needs some more. So this is the problem, right? You're working with unknown solder that doesn't melt very well, but it's probably cheap like dirt. There we go. So there's the first relay off. Let's get the second one off here. Get this melted. Wow, that does not want to melt. Come on. Let's add a bit of good solder to it, because that will often do the trick. If we get the good solder on there, it transfers the heat better, and it helps it to suck out the solder. There we go. That looks like it got a real good one that time. All right, let's get these other 3. Fortunately, this relay is a fairly heat tolerant component, so you can really heat it up and it's not going to do it much harm. Alright, let's see if we can get this one off. Oh, that's nice and loose. There we go. Alright, so we got that second relay off, and you can see here the traces on the top of the board that match the traces on the bottom of the board. So what we need to do is we need to cut those traces. And before we do that, let me clean off my soldering iron because it's grubby here. There we go. Clean off the soldering iron, give it a little tin here. Grubby soldering iron is a bad thing. There we go. All right. So we need to cut these traces. And the way that I like to cut the traces, I like to use just a rotary tool with a burr on it. So let's plug in the rotary tool here. And one thing that I will point out is that there's actually a fair amount of solder on these traces on the top. They're quite proud, and the reason that they do that is because if you add a lot of solder to it, it can carry more current. So let's see if we can get some of that solder off there, just to make it a little bit easier to cut the traces. We don't have to grind through the solder, so let's get this off of here. And on the other side of the board, they actually have it set up so that the solder mask goes right over it. They haven't over-tinned the solder on the top, but they did down here on the bottom. There we go. All right, so we're going to cut those traces with the rotary tool. And what I like to do, I cut this long one here, not the short one. The short one we're actually going to connect to the 5 volts. I like to cut them in 2 places just to make sure that they're cut. So I'm going to cut 2 places on the top and 2 places on the bottom. Here we go. And that looks like it's pretty well cut through. And then we'll do the top here, same trace, so the long trace again. There, that's good. All right, so now we've cut right through those traces. And we can get the multimeter. Here's the multimeter. So if we go from here to here, we have no connection. If we go to here, see we have a connection. There's no connection there, so we got that one cut. And there's no connection there, so we got that one cut. So we're good to go. We've got the traces cut. Now we can put the relays back on. So we just drop the relay in there, into the hole. Let's put this one on first. Get it lined up with the holes, and it should go back in nice and easy. There we go, it's in. Despite my manhandling it. There we go. All right, so the first thing that we need to do is we need to get this soldered back on here. And I find that it's very easy. If we put a little drop of flux on it, a little drop of flux down here, the flux just makes it solder better. And then we'll take the soldering iron, collect a little bit of solder, and then just touch this guy here, get him soldered. There we go, that one's soldered. And that's, which one did I do? This one here, right? There we go. So that guy's soldered in place there. Now we can solder the rest of it. Nice solder joint there. Nice solder joint there. Then we'll go back and we'll make sure that this one is well soldered. And this one. There we go. That relay's put back on. Now we'll put the other relay back on. And do the same thing. A little drop of flux there. A drop of flux there. And the flux, all the flux does is it makes the solder flow better. And I'm using flux core solder, but when I put it on the tip of my soldering iron like that, I've lost all my flux because it's all been melted. So throwing a little bit of liquid flux on there makes it solder much more easily. So that one's soldered in place, so let's just go ahead and finish it up. Oops. All right, this one here, this solder in there. Make it look nice, make sure this one's good. All right, there we go. So we're back together now. So the next thing we need to do is we need to make these connections here. So we need to connect ground into the terminal on the relay. So we're going to bring ground over to here and here. So these are the cut leads on the relay. And we're going to bring 5 volts over to this screw terminal, which means we're going to bring 5 volts to here. And the way that we're going to do that, if you remember up on the top here, we've got ground and VCC, which is 5 volts. So this is ground, and this is VCC. So we can pull ground out of here and VCC out of here. So we need to open up those vias, which we'll do again with the solder sucker. Oops, I got my thumb on it and messed it up. Go, nice clean via. Not like this solder that they use. Throw a bit of my own solder on there just to try to help get that to melt properly. There, it looks like it's melted. There we go. Nice clean vias. All right. So now what we want to do, and this is a little bit inaccurate. So we need a current limiting resistor in here. And what that will do is if this gets shorted here, directly across like this, then this terminal of the voltage regulator would be connected directly to ground, and we'd burn that out. So we need a current limiting resistor. And what we're going to do is we're going to put a current limiting resistor right in here. And I'm going to use a 1K resistor, just because it's easy. And there's lots of 1K resistors available, so here's some 1K resistors. So let's grab a pair of 1K resistors. And then we need some hookup wire. So I've got a little piece of hookup wire here. Let's get this out. All right, so there's our hookup wire. So we need to connect in to here and here with ground. And this is ground up here. And then from here, through a resistor to here, and from here through a resistor to here. So the ground, I like to do it on the other side of the board. And the reason that I like to do that is because the resistors, when they sit on here, are quite thick. And this needs to fit into the bottom of the case here. And if you have the wire and the resistor running over it, it makes it too high. So I like to put the ground wire on the other side of the board. So let's take this one and cut it off. And we'll strip another end. And we'll cut that one off. These are way too long. And what we're going to do is these are going to go into the ground via. We'll put them both in there. And they do go in. You have to wiggle a little bit. Oops. I say they go in, they do actually go in. You can trust me, I'm going to show you they go in. There we go, they're both in there now. Oops, oh, crap ass. Am I allowed to swear on YouTube? I don't know. That wasn't really a swear though, was it? No wire in the hole. Come on, in you go. You want to go in. Be a good wire and go in. There we go. All right, so it's in. So let's solder these just so they're soldered. Soldering iron. Solder this in here. All right, we're nicely soldered there. We'll clip this off. There we go. All right, so these wires now are connected to ground. So what we want is we want one to come over here. And this controller very conveniently has a hole here. So what I do is I just push this down through the board, and we want it to be about that long. And this one here, we want it to be about that long. Let's clip that there. And then we'll give each of these a quick strip with the stripper. This one, strip. Okay, so we'll put this one down through this hole. We'll put this one down through this hole. You'll see here they come right out near that terminal that we need to connect to. All right, I'll give it a little drop of flux because I like to do that. The soldering iron in here and put a bit of solder on it. And that one's soldered. And that one's soldered. Easy as can be. Reduce the height of that solder a little bit. There we go. All right, so we've made the ground connection, right? So this connection here is made on both of those relays. Now the next thing we need to do is we need to connect through a resistor from the 5 volts down to here, to these cut traces right here. So what I like to do is I like to take a bit of insulation off of this wire. Cut ourselves a couple of pieces that are about 1/4 of an inch shorter than the leads on the resistor. And we'll slide this onto one side. There we go. The other resistor here. And there like that. There we go. And then we'll put the 2 resistors into this via that gives us 5 volts. There we go. They're both in. Oh, that one slipped out. All right, get in there. There we go. We're both in there now. All right. So now what we need to do is we need to solder this in on the top of the board, which is not difficult if we can get down in there and reach it. It's not difficult unless you do that. All right, where's my tape? A little bit of tape. So what we're going to do is we're going to tape it on there just so that they don't fall out like that. I'm going to use this high temperature tape here that we use for soldering. Fold the end over to make it easy to find. We'll just tape that on there. There. Now they won't fall out. All right, so we need to reach down in there and solder that, which I'm going to do. Try not to melt anything else that is important. Those are soldered in place. All right. So now what we want to do is we want to connect this down to here, onto there. So we're going to need a little bit more insulation. I lost that piece of insulation that I pulled off. Where did it go? Is that it? There's a piece right there. So we're going to need about that much insulation for this one. We'll put that on there. Clip this. And then on this one, we're going to need about that much insulation. Oh, that's a piece of wire. That's not a piece of insulation. All right, so let's try this again. There we go. All right. Get that on there. Get this down to here. All right. so a little daub of this stuff. Nope. All right, now a bit of solder. Just going to do it this way. That's soldered onto there. Get it lined up so that it's pretty. There we go. Not that it makes any difference at all. And then this one over here, same thing. We'll get it on there, get it lined up, get it soldered down. That's hot. All right, that's it. It's modified. So now what'll happen is when the relay switch on, we'll get 5 volts on these contacts instead of just having the contact short. So the next thing that we want to do is clean this because we've got rosin all over it now. So the way that I clean it is I use isopropyl alcohol, and I've got my little pan here with the Kleenex in it, and I've got my bottle of laboratory grade 99% isopropyl alcohol, which I'll pour into this cap. And then I just go in and scrub it with a little acid brush just to get it cleaned up, just to get rid of the flux, because the flux will actually corrode the metal if you don't clean it up. Unfortunately, the isopropyl alcohol, because it's 99%, it evaporates very, very quickly. So you can just get in there and really get the isopropyl alcohol on it. And then we'll rinse it. There we go. Dry it off. Give it a shake. Just to shake the isopropyl alcohol out of it. There we go. So that's what a modified controller looks like. Now, if we reassemble it, this is the Inkbird case, I believe. We need the Inkbird faceplate. That's not it. That's the Inkbird faceplate there. So this goes on like this. And this slides into here. Oops, the other way. Just like this. The resistors, you'll see the resistors are a little bit thick on the bottom, so you have to make sure that the end of the controller ends up under the little stays in the case, which it did there. So there we go. So there's a modified controller. Now, you probably want to see what this looks like. So let's actually turn it on and show you how it works. All right, so I had a couple of LEDs somewhere on my desk. If I can find them. Oh, there's one. And there's the other. All right, because there's a current limiting resistor inside, you remember that we put in a current limiting resistor, we can just put an LED directly onto these contacts because the current limiting resistor will keep it from blowing up. So if we go in here and put this guy in here, this one in here. Oops, I missed it. There we go. All right, and then we need a sensor. Where did I put the sensor? It was up here on the desk. I had it. I know I had it because I showed it to you. Here it is. So the sensor goes in here. So this now goes in here, like this. We'll tighten this down. And then we need power. I have the power cord. Oh yeah, here it is. Here's my power cord. So line goes here and neutral goes over here. So we'll put line in. Oh, I've got to open it up first. Line and neutral in. All right, so were this just a standard controller, when we power it on, these would either be, the terminals would either be disconnected or connected. And if they're disconnected, nothing will happen. If they're connected, if they're shorted, nothing would happen. Now, if we've done this properly, when we turn this thing on, it's going to put 5 volts on one or the other of the terminals. So one of these LEDs should light up. Let's try it and see what happens. There we go. So now you can see we've got 5 volts here. And if we, see if I can get an ice cube out of my bottle of water. So if we cool this down, you'll see here the temperature's going down, 18, 15, 14, 12. I think the set temperature is 10. It is. And there you can see now it's heating because it thinks it's too cold. And then if we warm this up again, you'll see it switches to cooling. So what we've done is we've created a controller that can control the solid state relay. And I can show you that too. Here's our solid state relay. So let's hook up to the solid state relay. Where did I put my screwdriver? There it is. All right, so this is the negative side. So by convention, negative is black. There we go. And then positive is red. All right, let's take this LED out of here and put the solid state relay into here. All right, so there we go. So now we're connected up. So now we have the solid state relay where the LED was. And it's on the cooling side, and I've got it set for 10 degrees. So it's going to think it's too hot, and it's going to turn on the fan to cool. And what should happen is when we plug this in, this thing should switch on the solid state relay, which will turn this LED red. So let's see if that happens. There we go. So now what we've got is we've got this little controller that really can't control a big load for any length of time. And yes, it will do 10 or 15 amps a few times, sometimes for a couple of months, sometimes for half a year, but eventually it will burn out. So what we've done is we've now got this little cheap controller giving us 5 volts when it wants this thing on, powering this solid state relay that will switch 40 amps at 380 volts. So at 110 volts, it'll switch close to 100 amps, which is way more than we're ever going to need. So that's it. That's how you modify one of these cheap Chinese controllers to control a solid state relay. Thanks for watching.